Might as well show you how I did the top rail and some of the changes that we made. The one thing that I won't go into is putting in as many of the perforations as well as the flying lady, just for the simple fact that it is a super memory hog. It literally slows the computer down to the point where I'm waiting probably close to a minute, minute and a half to actually getting any modifications like these hems that we changed. Those took probably about 2 minutes before it would actually update the drawing, or update the model for that matter. And then it would take another 30 seconds to update the drawing. So let's just go ahead and recreate the profile and create the sheet metal part. I'll throw in some of these perforations and show you how I knocked out this area here by suppressing those features. So let's go ahead and get started. We know that it's 14 gauge. The overall length is 119 7/8, and the overall flat pattern is 6.81. Let's make the part, actually let's open up the part and find out what I made these. I think this lip back here was 1 inch and this one up front was 5 inches, but we'll just verify that real quick. Well, hopefully real quick. Like I said, it takes a little bit to do any modifications to it, so just looking at the sketch we should be alright, but we'll find out here in a second. Like I said, this part with all those features and the cutouts of the flying lady, there's so many facets and vertices and whatnot in there that it slows it down. My memory, or my graphics card, isn't strong enough for it. Okay, let's take a look. Very top, the contour flange, I'm going to expand that, and I'm going to look. I'm not going to double click on it or else it'll edit it, but I'm going to zoom up on it, and it is 1 inch by 5 inches. So let's go ahead and start. So I'm going to go File, New, and I always use the shortcut commands, but you can come up here at the top left, File, New, wait for the dialog box to open up, and we'll go to the sheet metal, B-Van sheet metal. And what I'm going to do is I'm going to draw the end profile. That is the easiest way to do this. I'll just draw a rough sketch of the end profile, and then I'm going to come into the F of X. I'm going to take out, as usual with the sheet metal, the length we can leave in there because that doesn't have any end bends. If it had end bends on it, then I would take the length and the width out. But since we know that this is going to be 119 7/8, we'll go ahead and leave that in there. I'm going to right click and I'm going to delete this parameter. I'm going to add a couple extra ones. I'm going to say that the, let's call this the H flange, H_flange is 5 inches long. Add another numeric, and let's go V_flange is 1 inch, and we'll save it there. Don't need to export these since they're not being used anywhere in a drawing or export it out to a different part. So we can type in V_flange, doing dimensions, H or D for dimension, click on the line that you want to dimension. This one is the H_flange, and now we have our profile of the top rail. So from here to here. So let's go ahead and go to sheet metal, set up our sheet metal defaults, click on 14 gauge stainless steel, apply that, and then let's go to underneath the sheet metal tab again, contour flange. Make sure that it's going back the right way. As usual, you can flip it so that it's inside. We want it to be the outside, or you can go the mean, which I've never used. But let's go this way. I'm going to go the width or the length of the part, and we're going to type in length, or you can come over here, click on this, go to list parameters, and list the length, track it down right there. Don't need it twice though. Again, I use the mid plane, so it's going to extend it out in both directions from the mid plane. Go ahead and apply it. And there's our part to start out with. I'm not sure why. There we go. 304. So we got a 304 stainless steel. It's semi-polished. That's fine. Actually, I'm gonna change that real quick. Let's go semi-polished. The only difference that I changed there was one that was 1 and 2, just different types of polished. We're just going to use the standard semi-polished. And then let's place the hems on the part. So I'm going to come up here to, again, underneath of sheet metal, go to hem, and we want to change this type. Instead of having it a single bend, which that was the problem that we were having, is they were smashing it all the way flat. It requires a ton of tonnage to smash the part. We're going to go with a teardrop. And I am actually going to go 198 just because I've already done this. I had to play around with this number, this angle here, to get it to the length that C&T wanted it to be so that it wouldn't crash into the brake press. I'm also going to change this radius. And what they're going to do is they're going to use a 16th die for 14 gauge. So I'm going to put in a 16th there. And I'm going to come back over here. Select edge, and I'm going to select the top edge. Oh, let's deselect that. So I'm going to hold down on the control key, and deselect, if I can, deselect that edge. All right, it's not letting me, so I'm going to cancel out of that. I'm going to come back into hem, click on the bottom edge, and you can see that it's smashing that again. So I'm going to come back up here, go to teardrop. And it remembered the previous settings, the 16th of the radius, and then the 198 degree angle coming back. I'm going to go ahead and apply that. And I'm going to do the same thing to the top up here. Apply that one. And now we've got our top rail with the hems, the hemmed edge. So I'm going to look at the top view here. And I'm going to go ahead and create the flat pattern. And then I'm going to hit S for sketch and click on the face. And then I'm going to hit D for dimension, and I'm going to dimension this very vertical line here, the width of the part itself. Come up to the parameters and change that from D0 to width. Select this so that it's exporting and so that our drawing can pull up that width on that part. And now that is finished, you can finish the sketch. I'm going to go back to the folded part, and let's place some of those perforations. Now I'm going to reset. Here's a handy little trick. Let's say we want this to be the very top. Let's see if we can reset. There we go. So I looked at the top, and I wanted this to have it so that it was horizontal. Same with the lettering, instead of it having it turned sideways like that. So I right click on that, set current view as top. Now let's see what happens. I still don't like that isometric view, so I want this to be the isometric view. I'm going to click on this, click on the corner of the cube, the view cube, come back up here and set fit to view. Set current view as home. And now if I hit F6, it goes right there. If I pan around again, hit F6, it goes right to that view. So those are the views that I like to see, something like that. So let's zoom in on this and start creating some holes. So I'm going to go ahead, and there's a couple of different ways you can do this. You can either do it through a sketch, or you can do it through a hole feature. Since we're not tapping or doing anything special, I'm going to go ahead and do S for sketch. Double click my middle mouse button so I can get back down on here. You know what? I am actually going to pattern this so that it's based off of the center line here. So our circles are going to start straight from the center. And they're 1/4 inch holes. So I'm just going to create a few of these. I'm not going to get into creating a perfect pattern out of it, but I am just going to. So what I did do, I just jumped. What I did do is I used a constraint, this equals constraint. I hit equals on the keyboard, and I pick on that first one, and then I can make all of the other ones driven off of, there we go, driven off of this first one. So if this changes, let's go ahead and change it to 3/8. You notice that all of them changed. So now let's get these holes so that they're lined up and spaced properly. So I'm going to use the inside. I'm going to use this bend here, and I'm going to use this bend here. I am going to say that this should be 3/4 of an inch there. I'm going to move some of these up. Let's go ahead and constrain those so that they're all in line with the center of the part. I'm going to first start out with the vertical constraint, find my origin point. I just screwed something up. Let's go horizontal, off the origin point, off the center point of that circle. Now I can take my crossing window, left top, bottom right, and I'm going to go horizontal, since I know that this still didn't change the orientation even by changing the top view. So let's go ahead, move these up, hit D for dimension. I'm going to come off of the radius of that part to the center of the hole, drag off the dimension, reference that dimension so that if this dimension ever changes, this one changes as well. Now what I can do to space these properly is I'm going to hit D for dimension, go for the overall width, accept it because it's saying, hey, you don't need this, it's not going to drive the part, this is going to be a reference dimension, are you sure you want to do that? Yes, I am sure I want to do that. Now I can count how many spaces there are, 1, 2, 3, 4, and I can hit D for dimension, off the center, reference this, divided by the number of spaces. So that gives me my perfect spacing, and I go ahead and put the rest of the dimensions on, referenced off of that first one that I created. So now I've got my holes all set up. Now I want to place some additional holes that are staggered. Get that staggered center going on. Go ahead and just place that. I'm going to hit equals key and reference that first one. I'm going to go ahead and make this so that it's actually a nice clean dimension instead of this 0.822. But what I can do is I can click on the center of that one, pull it off to the side, click on that reference dimension, divide it by 2, and now I'm perfectly spaced. So let's go ahead and create a couple more circles. Let's do our crossing window. Let's do a horizontal constraint. Hit equals to make the constraint for the equals constraint come up, and now all of those holes are the same size. Still need to space them properly, so I can hit D for dimension, center to center, reference that dimension. Oops, sorry. Let's try that again. Center to center, pull it off, reference that dimension. Now we're good. Okay. Now let's pattern that feature left and right and see what happens. So I'm going to make sure that I'm in the sheet metal. You don't have to be in the sheet metal. You could go back into the sketch. You could do it from the sketch, but I'd rather do it from a feature. So let's go ahead and hit E for extrude and extrude each one of these features. One of the nice things about SolidWorks over Autodesk Inventor is I can actually come up here, select the sketch, and it'll pick all of these holes. That would be super nice if they had that. It does not. Oh, I need to go the opposite way. So I picked on all the holes, changed this to a cut, and I said through all. It was going the wrong direction. It was coming out towards us. We needed it to go down through the sheet, and now we're good to go. Now let's pattern this. So underneath of the sheet metal tab, rectangular, go to features. We can then come over to the browser, pick on the extrusion one, which is our hole pattern, pick on our direction, and you can see the arrow is sliding off this way. I can go ahead and pick it so that it's both ways now. And let's put in here, let's do, I don't want to get too crazy because if you do a bunch of holes, it gets really bogged down super quick. I don't care how fast your graphics card is, it will slow it down tremendously. The one thing I just did, and I want to look up, I'm actually going to expand this, come back over to the sketch, is this 13/16 reference. So if I double click on that, it tells me that that reference dimension number is D1428. So remember that. Let's go finish sketch. Now let's come back into the rectangular pattern. Pick on the extrusion. Pick on the direction. Go both ways. I'm going to go ahead and put D1482. Now I've forgotten what it is. I've forgotten what it is. I got to go back into the sketch. D1428. I just told you not to forget it. Need to take my own advice. Okay, so let's go back into the features. D1428. Let's go to the direction. We want it to be both ways. D1428. We want a quantity of 20. Now you see what's happening there is it's actually overlapping. So I need to take that D1428 times 2. There we go. So now you've got that pattern going both directions. And you've got a nice little pattern there, so you can change this. So we can go 40 and say okay. It'll take it a little bit because there's quite a few holes there now. But it's not nearly as bad as the original one. So that is your sheet metal top cap and how it was created. What I did do is when I placed the Flying Lady, I looked at, I based it off the origin point and started from there. I started a sketch actually prior to doing these holes. But once I had created the Flying Lady and then I created the pattern for the holes, I went back in and wherever that Flying Lady was at, like let's just say it's around in here somewhere, is you can find and pick the amount of holes that you want to hide. Let's go. I don't want all of those. I don't want that one. So I'm holding down on the control key to deselect those other holes. So every other one. So let's say the Flying Lady's right there. So I expanded the rectangular pattern, found the holes that I wanted, and then I'm going to right click and I'm going to suppress those holes. Now when you create the DXF file, or if you do a whole quantity on your drawing, it's going to only count the holes that have not been suppressed. So all of the holes that are shown here, it's going to count those, but it's not going to count those in here that still exist, but they're just suppressed. Now if you change that feature to a hidden visibility, it will count the holes. So keep that in mind if you ever come across that and you're wondering why your drawing's still counting those additional holes. So now that's our part, we've got all the information, we can start the drawing from there. We don't need to. That's not what this tutorial is actually going to cover. So look it over and let me know if you got any questions. That'll do for now.